Just like all the data on your old iPhone can be perfectly cloned onto a new one your boyfriend gave you on Valentine's Day, some scientists believe that the information in the human brain can also be transferred or even entirely copied onto a USB drive or into another brain. In this video, we're going to explore the possibility of creating a version of immortality by backing up the human mind. Hi there, it's great to see you again. Immortality has long been one of humanity's oldest desires. Yet modern medicine shows that our physical bodies seem programmed to die after roughly 100 years. In 1961, Leonard Hayflick discovered that all normal human cells divide 40 to 60 times before entering a phase of aging and eventual death. Today, this is known as the Hayflick limit, and you can't build an eternal house if the bricks it's made of aren't durable, right? But that doesn't mean humans can't become immortal. You just have to look at it from a different angle. Many believe that humans are made of two parts, the body and the mind. If the mind could be separated from the body, we would no longer be bound by the Hayflick limit or the expiration date of our physical forms. Imagine this. One day, while cleaning your house, you stumble upon a hard drive containing 1 million Bitcoin from 2009. As of June 7, 2025, 1 Bitcoin is worth $104,580, which instantly makes you the 19th richest person on Earth. Suddenly, the hospital informs you that you have terminal cancer, 3 months left to live. Shut the hell up. You shout in despair. But then you remember, you've got $67 billion in your bank account. You immediately reach out to the world's top doctors to buy immortality. But they all shake their heads. Then someone walks in holding a USB stick and says, I can copy your brain onto this USB. With it, not only can you live forever, but you can relive your life at your prime anytime you want. Just plug it in, download, and install. Sounds amazing, doesn't it? This fun little scenario is something I made up to help you visualize one potential application of mind uploading. The idea of transferring the human mind into a computer. As the name suggests, it's the process of digitizing the brain, where all your memories, emotions, experiences, personality traits, and more are stored, and transferring it into a computer or robot, allowing that mind to continue existing even after the physical body dies. Through this method, futurists believe humans could extend life or even achieve digital immortality. But backing up the mind isn't just about eternal life. It also has other purposes, creating permanent backups to run on supercomputers controlling spacecraft, searching for life beyond Earth, sending astronaut minds inside ships that weigh just a few grams, withstanding vacuum, gravity, and cosmic radiation, enabling unlimited exploration, as long as the ship doesn't break down now. On a more personal level, minds living inside computers could become the final legacy after a global catastrophe. And if we're even more optimistic, these uploaded human minds might think faster and be vastly more intelligent than their original biological selves. When connected together, these minds could accelerate technological progress exponentially, leading us to the technological singularity. But while the idea is exciting, what about reality? Uploading a mind into a computer is such an incredibly hard task that it's been dubbed the final boss of neuroscience and neuroinformatics. Neuroscientists believe that our most essential functions, learning, memory, consciousness, are the result of complex physical and electrochemical processes in the brain, governed by the known laws of physics, chemistry, and biology. So, why hasn't anyone copied a brain onto a USB yet? In the past, many scientists tried simulating parts of the human brain. Based on those simulations, they estimated that if Moore's law holds, we might have the computing power to upload a mind within a few decades. But there's a catch. Moore's law predicted that chip power would double every 2 years. This was true from 1975 until around 2010. Since then, processing power has plateaued. In other words, we're approaching the limits of current hardware, but that doesn't mean humanity will never have the needed computing power. Because truthfully, no one knows exactly how much we need. The human brain contains roughly 86 billion neurons. Each neuron has thousands of connections, forming a network of over 1 quadrillion synapses inside our skull. The cortex alone has about 125 trillion synapses, roughly equal to the number of stars in 1,500 Milky Way-sized galaxies. And that's just the tip of the iceberg. To fully replicate a brain, we'd need to simulate nearly 100 billion neurons and 1 quadrillion connections. And each neuron is like a mini biological supercomputer. You can't just reduce it to a 0 or 1, or a simple on-off switch. To digitize even a single neuron, you'd have to model the structure and function of hundreds of trillions of atoms, plus the interaction rules between them. This would require a trillions of times more powerful than any we have today. According to a 2008 study, to simulate the entire human brain at the molecular level, you would need 10 core flops, about 8 million trillion times faster than today's most powerful computers, 38,800 terabytes of memory, equivalent to 78 trillion iPhone 15s with 512 gigabytes each. The most powerful computer today, like the Frontier supercomputer in the US, costs $600 million, has over 600,000 CPU cores and 8 million GPU cores, and uses 23 million watts of electricity. Yet it still achieves only a tiny fraction, 1/8,000th of what's required. As the old folks say, if something's too hard, maybe give it up and try something else. So, what's the alternative? One approach is to take pictures of the brain. In 2010, researchers at Stanford successfully imaged the synapses in a mouse brain. They sliced a super thin layer of brain tissue, just 70 nanometers thick, about 700 hydrogen atoms, then stained it with antibodies to make different parts glow in color. The images revealed something depressing. The brain is thousands of times more complex than we ever imagined. Each colored dot, a synapse, we once thought was just a simple on-off switch, turned out to be a microscopic biological processor capable of both information processing and storage. Each synapse could have 1,000 switches, and the human brain has more switches than all the computers, routers, and internet connections on Earth combined. In short, simulating the brain or digitizing the mind is a wild and sci-fi level idea. But that's also what makes it so fascinating. I'll be back with more updates on this in the future. If you enjoyed the idea of copying your brain onto a USB, please give this video a like, subscribe to the channel, and hit the bell so you don't miss out on upcoming science fiction content. For now, goodbye and see you next time.